Okay, in this question, we're going to look at palindromes. Okay, so a palindrome is a string that reads the same way forwards as in reverse. Okay, so a string is a palindrome if the string is the same when we read it from the left and from the right. For example, taco cat. The first and last characters are T, the second and second last characters are C, or A, the third and third last characters are C, and so on. Let the alphabet be the symbols A, B, C, D, and E. How many palindromes of length 11 exist over this alphabet, this 5-character alphabet? Okay, so what we're going to do is take our time with it. To solve this problem of finding the number of palindromes of length 11 over the alphabet A, B, C, D, and E, we can follow this solution. So again, a string is a palindrome if it reads this forwards as reverse. Okay, so what we're going to do is sort of split it up into 3 parts. So we have a string of 11 characters. So the middle character, which is the 6th character, it can be any character. It will be in same position either way if we go forwards or reverse. Okay, that's the first part of it there. Okay, so when you split it up into 3 parts, we're going to partition our string into 3 parts. So the first part, which I have underlined there at the bottom, the middle part, which is freestanding and there's no real restrictions placed upon it, whereas we have the last part, which I have overlined there. Okay, now whatever comes in the first part, which is underlined, automatically determines the outcome of the third part. Again, the overlined part there. Okay, so what we're going to do there is essentially what we're very specifically interested in is the string at the start. Now I'm going to call this string of length 5 S. X is a single symbol right in the middle, and really, apart from the fact that it can be one of 5 characters, that's all we can say about it. Whereas the reverse of the starting string, which I'm going to call S bar, is absolutely determined by S, the starting string. Okay, so really, it's S and X are what we're particularly interested in, and S specifically. Okay, let S be a string of length 5. Each position in S can be filled with any of the 5 symbols from the alphabet A, B, C, D, and E. Since S has 5 positions and each position has 5 choices, there are 5 to the power of 5 possible strings for S. The single symbol X, which is right in the middle, also has 5 choices. Now, just as a remark, for a palindrome of length 11, the 7th, 8th, and 9th, and also 10th and 11, I just went 7 to 9 there just for the sake of brevity, are essentially determined by the 5th, 4th, and 3rd position. And again, the 10th and 11th are determined by the 1st and 2nd and so on. Because the string must read the same way forwards as in reverse. So there are no independent choices for 7, 8, 9, and 10 because they are strictly dictated by the corresponding positions earlier to ensure the palindrome property. Okay? So that's why we're not interested in, or there's nothing that can be said about the remaining 5 characters at the end. Okay, we have only one choice for each of them. So in conclusion, what we're going to say is as follows. The total number of palindromes is given by 5 to the power 5, which is S, times 5, which is X, which is 5 to the power 6. So that is 15,625. If you want, you could actually include 1 by 1 by 1 by 1 to actually sort of reference the 7th, 8th, 9th, and 10th, 11th. Character, so on. But anyway, that's sort of not really important. So there are 15,625 palindromes of length 11 over the alphabet A, B, C, D, and E. Okay, we'll leave it there.